Okay, last time we looked at these 3 of our 8 or 10 functions, or however many we have. We have about 8, I think. And I translated it up and down, and I moved it from left to right, and I also put a negative in front and tipped it upside down. And in this particular function, and just for emphasis, I will associate these with the parentheses. In this particular instance, what I did is I didn't put 1 over x, I put 1 over x minus 3, and then outside I put plus 2, and I put a negative in front. This is going to do everything. It's going to translate this thing up 2 units, and then 3 units to the right, opposite direction of the sign, and then it's going to tip the whole thing upside down. And I'm just going to briefly show you, it's not a very good piece of chalk, is it? I'm going to briefly show you, remember that what 1 over x looks like. It looks like this. Notice I'm just sketching it, right? Because I've learned it, like you're supposed to learn. You're supposed to know these like the back of your hand, right? And so I know that in my head. I can see that in my head. Now all I need to do is realize, and I'm going to check to see if this is very visible on the camera. Appears to be. I didn't make this line very straight. I think I'll draw it again. If you notice, my t-shirt says something about some marine thing on the back. It's a pretty weird thing. I noticed that when I did it. I just happened to have an old t-shirt on. And when I decided I was going to do this, that's a little nicer there. Now notice this. It's going to be raised up 2 units. That's 1, 2. And I'll draw a fake x-axis here. I'll call that x hat. That's not a real x-axis. It's just going to help me draw the function. It's minus, so it's not moved to the left, it's moved to the right, opposite direction of the sign. 1, 2, 3, that's the 3 right there, right? Of course, this is 2, and I'll draw a fake y-axis there, and it's sort of like a crosshairs, and that's sort of my new origin right there. Now, all I have to do is draw my little function, right, which I know looks like this. I hope, oops, let me make that better. Like this and like this. It does not move up. It gets closer and closer to the x-axis. So, but it's also upside down. So this part is up there and this part's up here. So it's going to look like this. Now I don't know where the y-intercepts are, the x-intercepts, and at this point I don't really care. I'm just drawing, I'm just sketching it, and I'm not getting a very dark chalk, am I? I'm trying to get this as dark as I can to make sure that you can see it there, like that. There it is, okay? And that's curve sketching, and the idea is this, that you are graphing all the important features of the function. You're not trying to graph so you can get points or something. You have to put those into the function to get your graphings to show the behavior of the function. When you go ahead and take calculus, your calculus teacher here, just to show you, he'll say, well, we're going to look at the slope of y equals the cube root of x. And we all know the cube root of x looks like this, and like this. And I'm interested in the slope at 3, and look, we can tell, well, that's going to have a positive, small positive slope. He'll talk to you that way. And it's not so much the calculus as people will say, well, where do you get that graph? Well, they have I've got these functions from various calculus books. These are the ones they use, and they expect you to know these, expect you to be very good at these. So there it is.